everyone, welcome to EkEdu. So in this topic, I'll be teaching you how to find out these CFSE values for different octahedral complexes. Like I have told you, the splitting occurs because of when ligands come closer to the metal atoms. What happens? The the d orbitals which are present on the axis, they get more repulsions, or you can say they get more repulsive forces, due to which their energy increases and they are named as Eg orbitals, or you can say doubly degenerate orbitals, and other are named as T2G. The other way of saying it, I've told you earlier also, the other way of saying it's 2 by 5 delta O and plus 3 by 5 delta O. So let's find out the CFSE values. Before finding out the CFSE values, we need to calculate the pairing energy. What is pairing energy? Now, what is pairing energy? See, pairing energy is the amount of energy required to pair. It is the amount of energy required to pair electrons. It is the amount of energy required to pair electrons, or you can say to do the pairing of electrons. For example, and remember one thing, decrease in energy due to which the stability of the complex increases. Decrease in energy due to which the stability of the complex increases is called decrease in energy due to which the stability of the complex increases is called crystal field stabilization energy, that is CFSE. Decrease in energy due to which the stability of the complex increases is called crystal field. I'll write it here, CFSE. What is CFSE? Because in exam they can ask you which complex has the minimum CFSE, or which complex has the maximum CFSE value. So it is crystal field stabilization energy. This crystal field stabilization energy. Decrease in energy due to which the stability of the complex increases is called CFSE. Now, how to calculate CFSE? Like we have told you, this is how we have our d orbitals, 5d orbitals. 1, 2, 3, 4, 5. Now what happens? Here is the barycenter, means where the average value of energy is 0. But here, after the splitting, we have 2 Eg orbitals here and 3 doubly generate orbitals here. This is 2T2G. Now what happens? This gap, its value is minus 2.5 delta O or minus 0.4 delta O, whatever you want to learn. And its value is plus 3 by 5 delta O or plus 0.6 delta O. So how to calculate the value of CFSE? See, crystal field stabilization energy is equals to minus 0.5 delta O into number of electrons in T2G plus 0.6 delta O into number of electrons in Eg orbital. Number of electron in Eg orbital. So this is how we have to find out the value of CFSE. Now, if in case pairing energy is also involved, means if electrons are going to pair, then the value of CFSE changes and the formula becomes minus 2 by 5 delta O, number of T2G electrons, plus 3 by 5 plus 3 by 5 delta O into number of Eg electrons, plus we add P, pairing energy, the energy required for pairing the electrons. So these are the two formulas we have to use. Now make a star mark and write an important point. More negative is the value of CFSE. More negative is the value of CFSE, more stable will be the complex. More negative is the value of CFSE, more stable will be the complex. Now we don't have to discuss the case of, like, we already know strong field, weak and strong field ligands, right? Carbon first, the carbon, then nitrogen, then oxygen, and at that we have fluorine at halide ions. Yes, this is the order of ligands. Now, using this, we will start our calculating CFSE values for different electronic configuration. Suppose we have, okay, if I ask you to calculate DF, suppose this is weak field ligand, and here we have strong field ligand. So how will you write for D1? We'll calculate CFSE value for all the cases, okay? D1, D2, D3. Firstly, we'll calculate for D1. For D1 means we have this 5 orbitals. Yes, means 1 electron. And if 1 electron means we have Eg orbital empty and we have T2G orbital. In both the cases, if you see both the cases, diagram will be same. Even in case of strong field ligand, the diagram will be, the picturization will be same because we have only 1 electron present with us. So it's T2G, yes, and it's Eg. Empty, this is T2G, right? So what happens here is CFSE, the value of CFSE is minus 2 by 5 into 1 electron of delta O. It will be 0, e.g. there is no electron, so 0. So it will be minus 2 by 5 of delta O. Similarly, this case also, D1 CFSE is equals to minus 2 by 5 of delta O. Right? Let's discuss D2. Both in weak field ligand and strong field ligand. D2. D2 will also, picturization will remain same. Yes, for D2. Yeah, it will be. Yes, so I'll not draw for both of them. It will be T2G, 3, 2, 1, 2. So it will be 1, 2. So what is the value of CFSE in both the cases? It will be CFSE is equals to minus 2 by 5 into 2 delta, which is minus 4 by 5 delta. Similarly for D3 also, in both the cases of weak and strong. 1, 2, 3. Eg will be empty. Yes. And we have only T2G orbital. 1, 2, 3. So what happens? CFSE will be minus 2.5 into 3 delta O, which is minus 6 by 5 delta O. This is the value, right? Now, if you see these cases, if you simply see minus D1, D2, D3, the value of CFSE, whether you take strong field ligand or weak field ligand, it will remain same. Let's calculate for D8, D3. Let's calculate for D8, D9, D10. Then we'll do for other cases. Let's calculate for D8. Let's calculate for D8 CFSE. If it's weak field ligand and if it's strong field ligand. weak field ligand. It will be 1, 2, 3, 4, 5, 6, 7, 8. 8. So weak. 1, 2, 3, 4, 5, 6, 7, 8. Right? So value of CFSE will be minus 2 by 5 into 6 delta O plus 3 by 5 into 2 delta O. Its value will be minus 6 to the 12. 12 by 5 delta O plus 3 to the 6 by 5 delta O. Its value becomes minus 6 by 5 delta O. Similarly, for strong field ligand, if you try, yes, 1, 2, 3, 4 pairing for, yes, 8. This is how pairing will be done, but on splitting, we'll get T2G 1, 2, 3, 4, 5, 6. If you see the diagram after splitting, it will be similar. So CFSE value will also be similar in case of D8. Yes. And in D9, what will be the values? In weak field ligand and strong field ligand. So it will be 1, 2, 3. Let's make it here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So 6 we have to fill in D2G. 1, 2. 1, 2. Yes, 6, 7, 8, 9. Very center, right? Its value is minus 2 by 5 delta plus 3 by 5 delta. Similarly, in case of strong field ligand also, it will be similar because 1, 2, 3, 4, 5, 6, 7, 8, 9. So similar will be the scenario in case of D9, and the values will be similar 1, 2, 3, 4, 5, 6, 7, 8, 9. So CFSE value, if you want to calculate for D9, it will be 6 into minus 2 by 5 del O plus 3 by 5 del O into 3. 6 to the 12 plus 9 minus 3 by 5 del O. Now in case of D10, last D10, whether strong weak ligand or weak field ligand, it will remain as it is 1, 2, 3, 4, 5, because all the d orbitals are filled, so therefore all the T2G and EG orbitals will be fully filled. So we have this 1, 2, 3, and this is EG 1, 2, 3, 4. So here it will be 6 into minus 2 by 5 delta plus 4 into minus 3 by 5 delta. 4th is at 12, 6 to 12. So it will be, this is plus, minus plus, it will be 0. So CFSE will be 0 in case of D10 orbital. Yes, right. So can we make a point here that whether the ligand be strong or weak for D1, D2, D, we've just done it by ourselves, right? So let's make it a point, star mark this point. D1, D2, D3, D8, D9 and D10. For all these configuration, electronic configuration, CFSE will be same. It will be same for both weak field ligand or strong field ligand. Now we have to discuss 4 cases: D4, D5, D4, D5, D6, D7. In 4 cases, we have to discuss about the strong field ligand and the weak field ligand, right? So first we'll start with D4. What happens in weak field ligand and what will happen if we have strong field ligand. See, I'm not including pairing energy terms for now, right? But we know whenever pairing of electron takes place, we have to reconsider about the pairing energy also. V1, 2, yes. So 1, 2, 3, 4. Since it's weak field ligand, so what happens? This is Eg, this is T2G. So 1, 2, 3, 4. If weak field ligand, pairing energy is not very high. Therefore, electron easily jumps from T2G orbital to Eg orbital. What happens in case of this? Delta O is less than pairing energy, right? Therefore, electron jumps. Pairing does not take place. So, what is the value of CFSE? 3 into minus 2 by 5 del O plus 1 into 3 by 5 del O. So it will be minus 6 plus 3. Actually minus 3 by 5 del O. Minus 6 plus 3. Yes. In case of strong field ligand, now what happens? 1, 2, 3, 4. In case of strong field ligand, actually del O, the difference between T2G and Eg is very large. Therefore, the electron is not able to go to Eg orbital. So 1, 2, 3, 4. By mistake, I have drawn an electrons here. There will be no electrons here. Because we have only 4 electrons, we are talking about D4. This is Eg, this is T2G4. What is the value of CFSE? CFSE value in case of strong field ligand is minus 2 by 5 del O into number of electrons 4. So it will be minus 8 by 5 del O. Minus 8 by 5 del O. So if you see the values of in case of weak field ligand and strong field ligand are different for D4. Next, D5. If we have weak field ligand and if we have strong field ligand. Then we'll discuss D6. Last, we have to discuss D7. So these all cases we have to discuss in today's lecture. You can try these cases yourself also and then check your answers. What happened? D5. So 1, 2, 3, 4, 5. Now since it's weak field ligand, so electron jumps from T2G orbital to Eg orbital. Yes, it's T2G3, Eg2. So CFSE will be 3 into minus 2 by 5 of del O plus 2 into 3 by 5 of del O. So minus 6 upon 5 plus 6 upon 5 is 0. So CFSE is 0 in D5 when we take weak field ligand. Yes? Or you can say in case of high spin complexes. Weak field ligand forms high spin complexes. Strong field ligand. Now for strong field ligand, pairing takes place. So 1, 2, 3, 4, 5. And this is this. So Eg is empty and T2G has 5 electrons. So CFSE in case of strong field ligand is minus 2 by 5 of 5. So which is minus 2 del O. Which is minus 2 del O. I hope this is clear to you. Yes. It will be minus 2 del O. Next, D6. We'll quickly discuss these cases. Weak field ligand and strong field ligand. Now what happens in case of weak field ligand? We know that T6. 1, 2, 3, 4, 5. Yes. And we have 6 electron here. So weak field ligand. T2G 1, 2, 3. Eg 1, 2. Then 6 electron comes here. So it's T2G 4, Eg 2. So CFSE value become minus If I simply write it as its value is actually, if I simply 0.4 minus 0.4 and its value is plus 0.6 del O. If I simply use these terminologies, 4 is 16 minus 1.6 del O plus 6 2s are 12 plus 1.2. So it is minus 0.4 del O d6. Yes, in case of, and what will be the case? In case of strong field ligand, it will be T2G6 itself. Yes. So 1, 2, 3, 4, 5, 6. So this 1, 2, 3. So it will be, simply calculate 6 into minus 0.4 del O. It will be minus 2.4 del O. And more is the value of CFSE negative. It means more stable is the complex. Right? Next, D7. Last case. Weak field ligand. And we have strong field ligand. 1, 2, 3, 4, 5, 6, 7. Weak field ligand. What happens in weak field ligand? 1, 2, 3, 4. This is T2G and this is EG. So 1, 2, 3, 4, 5, 6, 7. So CFSE value is minus 5 electrons, 5 fours are 20, minus 2.0 del O plus 6 twos are 12, 1.2 del O. Its value becomes equal to minus D7. It becomes minus 0.8. And case of strong field ligand, we have 7, right? 1, 2, 3, 4, 5, 6, 7. This. So what happens in T2G? 1, 2, 3, 4, 5, 6, and 7th orbital. 7 electron jumps into EG orbital. EG. And this is T2G. This is pericenter. What happens? CFSE value minus 6 fours are 20, minus 0.4, so 6 fours are 24 plus 0.6. So it will be minus 1.8 del O. So if you see these results again, you will find that the CFSE values in case of D4 to D7, they differ and they depend on the kind of ligand present. See, weak field, here also values are different, here also, and here also. I hope you have enjoyed this lecture. In the next class, we'll discuss about the tetrahedral complexes. Till then, keep watching and keep learning.